We have a function f of two variables given by alpha times tangent inverse of x over y. If alpha is a constant, we'll need to find out the value of the partial of f with respect to x and partial of f with respect to y. So let's begin by considering whatever we are provided to us. So we have the function f given by alpha times tangent inverse of x over y. Let's take the derivative of this particular function f with respect to x will be equals to alpha being a constant, so we can take it outside and multiply it to partial with respect to x of the inverse tangent of x over y. Now we know that the derivative of the inverse tangent function ddx of tangent inverse of x, so that's given by 1 over 1 plus x squared. So we'll use the standard formula to find out the derivative, partial derivative of the inverse tangent function, which will be 1 divided by 1 plus, so instead of x we'll have x over y and square it, and we'll also need to apply the chain rule, so we'll multiply it to partial derivative with respect to x of x over y. Fine, so this gives us alpha times, so here we have y squared divided by x squared plus y squared. Now since we're taking the partial derivative with respect to x, so y will be treated as a constant, so we can pull it out of the derivative. So we have 1 over y multiplied to partial with respect to x of x. Right. So partial of x with respect to x, that will be equals to 1, and this gives us the value partial, write it here, partial of f with respect to x, so that will be equals to, so here I have 1y from the numerator in the denominator cancelling out, and this value goes to 1. So this gives us alpha times y divided by x squared plus y squared. Now we'll try to find out the partial of f with respect to y. So we'll consider the same equation, the original equation, and we'll take the partial on both sides with respect to y, which will be equals to alpha. So alpha is still a constant, so we'll multiply it to partial with respect to y of the inverse tangent of x over y. Let's find the value now. So we have alpha times 1 divided by 1 plus x over y whole squared, so this will be multiplied to partial with respect to y of x over y. So that gives us alpha times y squared divided by x squared plus y squared multiplied to, so here since we're taking the partial derivative with respect to y, x will be treated as a constant, so we can pull out that x, and all we have to do is find out the partial derivative with respect to y of 1 over y. The partial derivative of 1 over y will be simply negative 1 over y squared, so that means we have alpha times y squared multiplied to x divided by x squared plus y squared, and the partial derivative of 1 over y will be negative 1 over y squared. So here we have obtained the value partial of f with respect to y, so that will be equals to negative alpha times, so here y squared and y squared will get cancelled out, negative alpha times x divided by x squared plus y squared.